Hello and welcome back. Last time we talked about kinematics and we defined some important quantities that we need to be able to fully define an object's motion or the study of kinematics. And I've just summarized here at the top these quantities again. Remember, position gets the symbol x, displacement gets the symbol delta x, that's the change in position. Distance gets the symbol d, and this is just the total ground covered. Speed gets the symbol s, which is the distance an object travels divided by the time it takes to travel that distance. Velocity gets the symbol v and is displacement over time. Acceleration gets the symbol a and is change in velocity divided by time. And time, of course, gets the symbol t. So now let's look at how these quantities, just a few of them, are completely defined. I want to look at displacement, velocity, and acceleration. How are they related to one another? Well, displacement, again, gets the symbol delta x. And this is, as you recall, just change in position. Velocity is the change in position divided by the change in time. Notice that this formula has a kind of familiar relationship with position and time. Recall back from your studies in math that you were introduced to the slope formula. So this is from math. And remember, we used the symbol m when we were studying slopes in mathematics. And the slope was equal to the rise, the change in the vertical coordinate, divided by the run, the change in the horizontal coordinate. So if we had a graph, x on the horizontal, y on the vertical, as is standard in math. And we have a curve, let's say a curve that is a line, looks like this. Then the slope of this line, m, can be found by just taking 2 points. So we could take this point and this point. This point right here has a y coordinate. This point right here also has a y coordinate, so we'll call that one y2 and this one y1. This point right here, while the object is at y2, is also at x1, at x2. And y1 will correspond to some x1. So this could be an object that is traveling in space, and we're plotting out its position along the horizontal and along the vertical. And here it is at some point P2, and here it is at some point P1. So the slope can be found, m, as y2 minus y1. That's the rise, divided by the run, which is x2 minus x1. Well, notice that if we change the axes, we can use this same information that we gleaned in our math classes and transfer that information to looking at how velocity is related to position and time. So velocity is going to be equal to some final position minus some initial position divided by some final time minus some initial time. Notice this is rise over run on the position versus time graph. So if we have a position versus time graph, position on the vertical, time on the horizontal, we have an object, let's say, that is traveling, again, at some curve, can be described by a straight line again, and we look at two particular times, this one being T2, an object is at location X2. At some earlier time, T1, 1, the object is at position x1. So notice that velocity then is the rise over the run on the position versus time graph. And this is a very important piece of information. So velocity is equal to the slope on position versus time graph. What about acceleration? Well, we can use this same information that we learned back in our math classes to transfer it as well to how acceleration is related to velocity in time. So remember, our definition of acceleration was that acceleration is equal to the change in the velocity over the change in time. This is the time that corresponds to the velocity's change. So in other words, this is some v2 minus v1 divided by x2 minus, or t2 minus t1. So again, this is the rise over the run on the velocity versus time graph. So let's go ahead and draw the velocity versus time graph. And let's say we have an object that again is moving in some linear fashion, velocity with respect to time. So this is increasing velocity over time. And we look at some time t2, and it will correspond to some velocity v2. And some earlier time t1 will correspond to some velocity v1. So acceleration then is the rise over the run, or the slope, on the velocity versus time graph. So acceleration is equal to the slope on velocity versus time graph. These are going to be some very important relationships. And if you have had calculus, you know that you can find a slope at a point. This class doesn't assume that you have had calculus, so we will use a tangent line to find or approximate the slope at a point when we have something other than a line, in other words, a curve that is not a line. So let's look at that next time, and we'll look at how some of these graphs are related to one another now that we've kind of laid down the foundation of how we can transfer information from one graph to another quantity. So we'll see you next time.